Good morning, good evening to everyone. We have a couple of talks planned on OvS Offload. This is the first one in the series. In this talk, uh, I'll go over different models of OvS Offload and talk about its pros and cons. Quickly introducing myself, I am Hemal. I lead system architecture team at Broadcom in the Ethernet controller product line division. My journey with OvS Offload has been for quite a number of years. 5 years ago, there was no offload that existed for OvS Offload. Uh, Now we are at a point where we do have offload models, but the current state has its own challenges. So for the agenda, I'll first introduce different terminology for OvS Offload, which will help with understanding different models. Then I'll focus on going over different offload models for OvStpdK as well as kernel data path offload model, give a comparison of all this, and then summarize where we are. So with that, let's dive into the presentation. As we know, OvS has been very successful, open source, widely deployed vSwitch in cloud and enterprise environment. OvS is built on flow processing that is based on fundamentally match and action. On per packet, you are matching a packet to a specific flow and performing a set of actions on it. OvS offload in simplistic term is basically offloading that match action processing from software layers of OvS. If you look at different aspects of offload within that, there are a couple of partial offload models, and then there is a full offload. The match offload basically refers to just offloading the classification or match piece of OvS to help with the software processing. This applies to receive side only. For the action offload, this is the case where partial offloading of actions are being handled by the NIC. It applies to both transmit and receive direction. And in this one, the OvS software layer performs a set of actions, and the remaining subset of actions are performed by the NIC. An example of this is connection tracking could be handled by the OvS, but then the NCAP and DCAP functionality are being offloaded to the NIC. OvS is still in the data path. And then the full offload, this is where we refer to OvS data path is bypassed, and then entire match and action processing is handled by the NIC. This is the full offload model. Why offload? We know the software complexity and processing as actions get complicated impacts the throughput, packet processing efficiency, and the latency. By offloading these functions, whether it's a partial offload or full offload, you improve the throughput of the OvS. By saving those cycles, efficiency of packet processing improves, as well as the latency in the data path reduces. So those are all the partial match offload, action offload, and the full offload model. In next few slides, I'll go over these offload models and talk about their pros and cons. So to begin with, OvStpdK, this is the user mode implementation of OvS, which allows VMs using Vertio to be connected to the network via OvS. OvStpdK provides VM to VM and VM to net connectivity. The flow processing is handled in the user mode, and underneath for the packet layer communication, it uses DPDK pole mode driver, whether it's a physical function or a trusted virtual function that's being used to provide OvS connectivity to the physical uplink port. In this OvStpdK, the partial match offload has been well integrated. This is via RT-Flow API. RT-Flow represents a set of APIs for offloading flow processing in the DPDK environment. It's been upstream in DPDK and it's been used by OvStpdK. So that's one of the partial offload. Since 2.12, it's been part of OvS DPDK. We started discussion on partial actions offload last year, and this year we submitted a number of proposals to do partial actions offload both in transmit and receive path. And what we ran into is inherently the architecture challenges and complexity of OvS offload layer. We have a talk after this where we will get into more details, but because of those reasons and not having action offload being upstream in the OvS version, we were not able to characterize actions offload benefits. So this is one of the challenge with the partial action offload. I'll move on to the next one is the full offload with SR-IOV. So with SR-IOV, the benefit is you are bypassing the hypervisor. You're bypassing the hypervisor vSwitch, in this case, OvS, and you're directly having VMs communicate to the NIC via VF, and that is via VF driver. In order to realize the benefits of SR-IOV and still apply the OvS policy, this OvS DPDK full offload model has been supported. It basically is based on representation of virtual functions in the OvS domain via VF representer. Through the combination of this VF representer and the control plane of RTE flow, this full offload model is realized. The OvS software layer still, until the flows are learned, it handles all the packets to and from the VMs via VF representer. Once those flows are learned, they are fully offloaded to the NIC. From that point onwards, the traffic from VM will be directly communicated to the NIC via VF, and the entire flow processing will be handled in the NIC. So that is the full benefits of offload, which results in OvS bypass. As I mentioned, the control plane infrastructure is in place. Those are benefits. This model also has its own challenges because it relies on the VF driver, vendor specific driver in the VM. It doesn't allow you to support live VM migration services. That's one of the challenge. Also, the OvS specific challenge this model poses is OvS has this two bridge model for tunnel processing, where in the first bridge you are handling the vhost side of it and the second bridge handles the tunnel. This presents significant challenges with tunnel decap offload. And currently that solution, what started as a proposal from the two flow, how to handle that from the offload standpoint, is not being upstream in 2.14. So these are some of the challenges to realize the full offload benefits via this model. Next one is a slight variant of the previous model where we are preserving the Vertio driver model in the VM by having this OvS bridge forwarding between the vhost and VF PMD. The remaining RTE flow and VF representer infrastructure, what I mentioned on the previous slide, is applicable here. So this model gives you the full benefit of full offload, and flow processing layers are bypassed from the OvS. And then the control plane infrastructure, which is already there, is being leveraged. The challenge is here, the tunnel decap offload challenge still remains for this model. Also, in order to preserve the Vertio model in the VM, you added this software forwarding layer, which reduces some of the offload benefits. So those are three OvS DPDK offload model. The first one, the partial, within that we had match and action. Match offload is well integrated. Action offload has its own inherent challenges with the offload layer design. OvS DPDK full offload model with SR-IOV, one that preserves the vhost, which is shown here in the previous one, where you are bypassing the OvS completely, but it requires a VM driver VF driver in the VM, which are vendor specific driver, which doesn't support live VM migration, while this model does support it. Next one, this is probably the oldest offload model that has existed. Started with OvS kernel TC flower base and the VF representation and use of switch dev framework for management plane. With this model, works with the SR-IOV where VMs are directly attached to a VF, and they are having VF driver, vendor specific driver running inside the VM. In this model, the flows are still learned by the OVS, and once those flows are learned, they're offloaded in its full form from match and action processing standpoint to the NIC. And from that point onward, VM traffic directly flows through the NIC and flow processing is applied by the NIC. This model also realizes full benefits of offload and OVS bypass, but it does require vendor-specific VF driver in the VM. It also doesn't support live VM migration. And because the infrastructure for the control plane resides in the kernel, it's based on kernel data path. If you are using user mode appliances where you want to have your switches reside there, this model is not applicable for those environments. So that's the OVS kernel data path full offload model with SR-IOV. So as you can see, OvS offload from where it was initially, where there was no offload, it has come a long way. There are several OvS offload models that exist today, and they all have their pros and cons. There is no one model which fits all application or use cases. So it is important for you to understand what are the benefits that each offload model gives and what environment it fits in. As we discussed, partial action offload model preserves the Vertio, supports the live migration, but it doesn't do the OVS bypass. The OvStpdK full offload models, both user mode and kernel with TC flower with SR-IOV, they do bypass OVS, but it requires vendor-specific VM driver, which doesn't support live VM migration. With OvStpdK, we have this vhost full offload model, which preserves the Vertio model in the VM driver, but it has overhead of forwarding layer in the user mode, but it does bypass OVS. So as you can see, the complexity of different OVS offload model, offload layer design, and different models gives you many choices, each one with its pros and cons. So the current state where we are, from where we started with no offload, we have come a long way. We have many different models for OVS data path offload, both for user mode and kernel mode. The control plane OVS offload layer continues to be challenging, and it's inherent in the design of it. We ran into this with action offload, where inherently the architecture and OVS offload layer design prevented to have a simple action offload model being upstream. And then full offload model, the infrastructure exists today, but there are issues with the offload design layer as well as with the VM migration. So in summary, from where we were come a long way with OVS offload model, but with many models and complexity of OVS offload layer, the deployment and adoption of OVS offload still remains challenging. My call to action to the community is the software vendors as well as hardware vendors, they need to work even closer to make OVS offload fully integrated in the OVS and part of the total solution, which can be deployed at scale and widely. With that, thanks everyone for listening. I'll end the talk here.